Hello and welcome to section 2.3, Postulates and Diagrams. Today we're going to look at interpreting and sketching diagrams. To begin with, we're going to look at 7 new postulates that's going to involve points, lines, and planes. So for the first one, we have what we call the 2-point postulate. And this just says that through any 2 points, you have exactly one line. So you can see right here, we have point A and point B, and there's really only one line that can go through those 2 points. 2.2 is similar in the sense that it says a line contains at least 2 points. So here, if we're starting out with a line, then we know that there's got to be at least 2 points. And in this case, we'll call them point A and point B on that line. For postulate 2.3, we have the line intersection postulate. And this says if 2 lines intersect, then their intersection is exactly 1 point. So you can see here we have line N and line M, and they are going to intersect at exactly 1 point, and that point here is labeled as point C. Postulate 2.4 is the 3-point postulate. And this just says through any 3 non-collinear, meaning 3 points that are not on the same line, there exists exactly 1 plane. So you can see over here that if I have 3 points that are not on the same line, that this is going to create a plane. Postulate 2.5 is the plane point postulate. And this says a plane contains at least 3 non-collinear points. So again, if we're given a plane, then we know that there's at least 3 points on that plane that can help establish that plane. Postulate 2.6 is the plane line postulate. And it says if 2 points lie in a plane, then the line containing them also lies in the plane. So you can see here we have 2 points, D and E, are on a plane, and we can connect those 2 points with a line, but that also tells us that that line is also going to be on that plane. And then the last postulate we're going to look at for right now is postulate 2.7, the plane intersection postulate. This says that if you have 2 planes and they intersect, then their intersection is going to create a line. So you can see if I have plane S and plane T, if they intersect, they're going to intersect at this line right here, which is going to be line L. So let's take a look at example 1 and see how we apply these postulates. For example 1, it says to state the postulate that's illustrated by the diagram. So if we look at this first one here, it says if, and notice we have 2 lines that are going to intersect here, then, and notice I have this little red dot here in the middle. So if I have 2 lines that intersect, then they're going to intersect at exactly 1 point. If you go back and look at your postulates list, we can see that this is what we call the line intersection postulate. And this postulate states if 2 lines intersect, then their intersection is exactly 1 point. And that's exactly what we have going on right here, where we have 2 lines here and here, and they intersect at that 1 single point. Now for part B, notice we have 2 planes. So here I have 2 planes that are intersecting. Then we can see that they're intersecting at this line right here. So if we go back and look at our postulates, we're going to say that this is the plane intersection postulate. And the plane intersection postulate states if 2 planes intersect, then their intersection is a line. Please pause the video, try this example, and then come back and double check your answer. For part A, notice it says if we have a line, then we have 2 points on that line. This is going to be our line point postulate. And the line point postulate states that a line contains at least 2 points. As you can see here, it's point A and point B. Now for part B, it says if we have 3 points, then those 3 points are on this plane. And notice our 3 points are not on the same line. So we can say that this is the 3-point postulate. And the 3-point postulate states that through any 3 non-collinear points, there exists exactly 1 plane, as you can see right here in part B. Let's take a look at example 2. So for example 2, it says use the diagram to write examples of the plane point postulate and the plane line postulate. So just as a reminder, the plane point postulate states that a plane contains at least 3 non-collinear points. So if we look at points B, A, and C, you can see that we have 3 non-collinear points, and those 3 non-collinear points are actually going to lay on a single plane, and you can see right here that that plane then is going to be plane P. So they all kind of lay on this plane right here, if you can visualize that. And as a reminder, the plane line postulate states if 2 points lie in a plane, the line containing them also lies in the plane. So here we have point B and point A, and those 2 points can be connected with line N here. And when you connect them, that line N is also going to lie on plane P, which you can see, again, plane P is this plane right here. So because points A and B are on that plane, then line N is also going to be on that same plane. Let's take a look at example 3. So for example 3, we're told to sketch a diagram showing that TV intersects PQ at point W so that TW is congruent to segment WV. So the first thing I'm going to do is I'm going to start out by drawing a line. And on that line, I'm going to place my 2 points, T and V. So I have points T and point V. Then I'm going to draw a point that's going to be a midpoint, and I'll call this point W. And I'm going to identify that this is a midpoint by putting the little tick marks that indicates that TW is the same length as VW. And then I'm told that TV intersects PQ at point W. So I now have to go out and draw a line PQ. So we'll just go ahead and draw a PQ that goes through W. Okay, and PQ is a segment. So I'll label this end as P and this end as Q. And PQ goes through the point W. Now, this is just one example. There's many different ways that you could sketch this. So if you have something different, that's okay. Please pause the video and try this example on your own and then come back and double check your answer. So for this one, it says sketch a diagram showing that ray VX intersecting line UW at point V so that ray VX is perpendicular to line UW. So the first thing I'm going to do is I'm going to start out by drawing a line. And I'm going to put my 2 points, U and W. So I'll call this U. This is point W. I was told that ray VX intersects UW. And VX is perpendicular. So here's my ray. We said that it intersected at V. And we know that this is ray VX. So I'm going to draw a point X on this line. I'm going to put my little right angle box in there to show that these two lines are perpendicular. And now I have, if we kind of reiterate this, I have line UW is going to be intersected by ray VX, and that's going to intersect UW at a right angle. So I think I've got all the requirements met on this. You may have something slightly different, and that's okay too. So when sketching and interpreting diagrams, we have a scenario where a line can be perpendicular to a plane if and only if the line intersects the plane in a point and is perpendicular to every line in the plane that intersects it at that point. Okay, now this is kind of confusing. It's really hard to draw, but you can tell if this is true because in any diagram, a line that's perpendicular to a plane must be marked with the right angle symbol as shown. So if you look in this drawing here, you can see right here that we have the right angle symbol to tell us that these planes are perpendicular to that line. So we kind of need to look for that if we have a line perpendicular to a plane. So let's take a look at our final example, which is example 4. So for example 4, it says, which of the following statements cannot be assumed from the diagram? So the first thing we have to look at are points A, B, and F are collinear. So I have point A is right here, point B is right here, and point F is right there. So you can see that all three of those lie on the same line. So we can say that A, B, and F are actually collinear. Next, we're going to look at points E, B, and D. And it says that E, B, and D are collinear. Well, if you look at E, B, and D, they may look like they're collinear, but there's no physical line going through them. So we cannot assume that they are collinear. So in this case, this is not necessarily true or cannot be assumed based on what we're given on the diagram. Next, we're told that line AB, which is right here, is perpendicular to plane S, and plane S we can see is right here. So because we are given the little right angle symbol right here, then that is true, that plane or line AB is perpendicular to plane S. Next, we're told that line CD, which is this line here, is perpendicular to plane T. Well, plane T is this vertical plane right here. There is no right angle symbol to indicate that, so we cannot assume that line CD is perpendicular to plane T. So in this case, this is not true. And finally, we're going to look at line AF, which is this line right here. And it says line AF intersects line BC, which just so happens to be right here, at point B. So point B is right here. And because line AC does intersect BC at point B, then we can say that this is also true. So the only two statements that are not true would be points E, B, and D are collinear, and line CD is perpendicular to plane T. Please let me know if you have any questions. Otherwise, we'll see you in class. Have a great day.